In this video, we will try to solve MCQ 1 and MCQ 2 from the book Concepts of Physics. The chapter is Electric Field and Potential. Objective 1 or MCQ 1 meaning is out of given 4 options, only one option would be correct, and objective 2 meaning is more than one option we may have correct, maybe 2, 3 or 4. In this question, there is a diagram given and we have to establish the relation between the electric field at A, B and C. We know that wherever there is gathering of electric field lines more with respect to another point, electric field would be more stronger at that particular point. So in the diagram, you can see at point A and C, field lines appear to be more closer than to the point B. It means at A and at C, field will be equal, but both would be much greater than the field appearing at particular point B. So here C would be the correct option. Question number 2. When the separation between two charge is increased, the electric potential energy of the charge. Electric potential energy may increase, may decrease until the nature of charges are not specified. For example, take this positive and negative. If the distance between them is going to increase, as per this formula, U, that is minus k q1 q2 upon r. If you are going to take q1 positive, q2 negative, it will be U is equal to k q1 q2 upon r, and it is going to increase positive. But if both are negative and then we are going to find the potential energy, it is negative and it is going to decrease as distance is going to increase, because increasing in negative, it means decreasing. Then if both are positive, again it would be having same value but negative, so here also it is going to decrease. In the question it is being asked potential energy of the charge or the charges, both are positive, both are negative, one positive, one negative is not specified, it means it may increase or may decrease. Question number 3. If a positive charge is shifted from low potential to high potential, suppose you are promoted from low post to high post, what will happen? Your lifestyle, your circle, your friend circle, everything will be uplifted. Similarly, when a charged particle is moved from low potential to high potential, 10 volt, 20 volt, 30 volt, if charge is Q, amount of work done will be accordingly 10Q, 20Q, 30Q. If it is positive, then potential energy is going to increase. At the same time, if we think it is negative, the potential energy is going to be negative, more negative, and it means it is going to decrease. But in question it is being specified that charge is positive, it means potential energy is going to increase. Question number 4. Two equal positive charges are kept at a distance A and B. The electric potential at points A and B, excluding these points, is studied while moving from A to B. Actually, in this question we have to find when we are moving from A to B, what would happen to its potential, potential energy of the system, both together A and B. As we know, if you think about the formula of the potential, it is nothing but kq upon r. It means V is inversely proportional to R. So for A only, if you are going to take the diagram or the graph of potential, it is inversely to the distance and it is appearing as you can see the diagram. For B, as we are moving from origin towards B, it is going to increase because we are going nearby the B. If we are going to replace both the graph by a common graph, it is appearing like this. It means first it is going to decrease and then it is going to increase. This particular question you can even solve by mathematical method because it is objective and we need to solve into the given interval of time, maybe 20, 30, 40 seconds. So no need to go for much tougher mathematical process. Rather you can take the graph. Even if you are not able to draw the graph, if you think that as we move away from a particular charge, potential is going to decrease. But at the same time we are moving nearer to the another one, potential would be increasing. So for that hit and trial method also you can click the correct option. Question number 5. Question number 5. The electric field at the origin along the positive x-axis is given. Electric field is along x-axis. There is a small circle and which is drawn by taking 4 points A, B, C and D, and the coordinates of 4 points are given. You can see x-axis A0, Y0A, and then x negative and then y negative. The coordinates are given. Electric field is E. The question is, out of the points on the periphery of the circle, the potential is minimum at. So let's now find the potential. We know that E is equal to EI because it is along x-axis, and the relation for the potential with the electric field is dV is equal to minus E dot dr. Let's put the value of E along I-axis and the displacement or the position vector along x-axis. We are getting the potential at particular point A as minus EA, because I dot I is equal to 1 as per the dot product. I dot I, j dot j, k dot k is equal to 1. Now at point B it is minus EI dot AJ. I and j both are of 90 degree, and dot product of different unit vectors would always be 0. So here potential at B would be 0. Similarly, potential at C, if you are going to multiply, it is EA but positive. Potential at D, because they are perpendicular, I and J would be 0 again. So B and D are contributing 0 potential or having 0 potential, but C and A are having some amount of potential where C is positive and A is negative. Hence potential at A would be minimum. Question number 6. If a body is charged by rubbing, see, if one particle is about to lose the electron and second particle is about to gain the same electron, one would be positive and two will be negative. What does it mean? That by friction, electron is getting transferred from one body to another and it is getting charged. So if it is positive charge, some amount of mass is going to shift from positive to negative. So positive charge is going to be slightly lighter, whereas the negative one is going to be slightly heavier. So mass may increase slightly or may decrease slightly. That will be the option. Slightly, why we are taking? Because the mass of electron is 9.1 into 10 raised to minus 31. Look at the order of magnitude of the mass. It is minus 31 kg. Very, very small amount. Question number 7. An electric dipole is placed in a uniform electric field. The net electric force on the dipole. This is electric field, this is the dipole. One charge is positive, another one is negative. Same amount of force but in opposite direction would be acting on the dipole. So same amount, QV, QV, opposite direction, QV minus QV. If you are going to add, it will contribute 0 force, or net force would be 0. Question number 8. There is a diagram given and the question is, there is a charge Q placed at the center, there is a point P, there are 3 points A, B and C. We have to carry another charge from P to A to B and C. What is the relation between or among their work done? So let us now first think that the radius or the distance from the charge Q given to point A, to point B, to point C will be same, and take it as R. Now let us write the potential of Q at point A. It is KQ upon R. At B, KQ upon R. At C, KQ upon R. Potential at P we can consider 0. If you don't want to consider 0, you can take any value. Take V, take 100 volt, 200 volt, any value. We just want to find the difference of potential between 2 points, that is point P and point A, then point P and point B, point P and point C. And here work done formula is change in potential into charge. So change in potential, if you want to calculate work done when charge is coming to A, KQ upon R minus 0 into Q. If you are taking 100 volt, 200 volt, X volt, Y volt, any value, the difference would be same in all 3 cases. And if difference is same, work done would be same. So work done in case A, B and C will be same. Question number 9. A point charge Q is rotated along a circle in the electric field generated by another point charge Q. The net work done by electric field on the rotating charge on one complete revolution is. You can take the example of electron and nucleus. Electrons are revolving around the nucleus and there is no net work done. You can think, or you can solve this question by another method, that suppose this is the particular point charge and the electric field lines are originated radially outward, We know that equipotential surface would be in form of concentric circles or concentric spheres, and if a charge is moving on this particular equipotential surface from one point to another, work done will be delta V into Q. Delta V is 0, so work done would be equal to 0. So there are two different ways to understand this question: by equipotential surface, which is concentric spherical for a particular point charge, or by electron or hydrogen Bohr atom of hydrogen atom, where electrons are revolving in non-radiating stationary orbits. The work done will be equal to 0. Now objective 2 question number 1 is there. The total charge of universe is constant, total positive charge of universe is constant, total negative charge of universe is constant, the total number of charged particles in the universe is constant, and we have to mark the correct option. So total number of charged particle in the universe is not constant because of transfer of charge from one point to another. It may neutralize one, it may originate, or it may generate another charged particle. So D seems to be incorrect. Total negative and total positive not constant, because in daily practice, even if you are going to charge your mobile phone, or you are going to rub your hair by a dry hair by a comb, number of positive and negative keeps on changing. But yeah, total charge of the universe can be considered as constant. So option A is the correct option. Question number 2, a point charge is brought near an electric field. The electric field at a nearby point, if it is positive, it may increase. If it is negative, it may decrease. But will increase, will decrease, because the extreme word used in the options we always prefer to neglect, and we can take may increase if positive, may decrease if negative. Question number 3, there are 4 options. We have to choose the correct one. First, E is equal to 0, V must be 0. No. E is equal to 0, V may be constant. Look at the relation. E is equal to differentiation of voltage with respect to position vector. So even if V is constant, E will be equal to 0. A constant non-zero. It is not necessary that V also would be equal to 0. Then second one, V is equal to 0, E must be 0. Take the midpoint of two equal and opposite charges. Where electric field is always towards negative charge, potential will be 0. So here potential is 0, but E is non-zero, not mandatorily. Then C also you can take in the same example. E is not 0 at the midpoint, but V is 0 at the midpoint. But here it is saying V cannot be 0. Then D, V is non-zero, E cannot be 0. Look at the first statement and just take into opposite order. If V is non-zero but constant, E is equal to 0. So out of these 4, none of the 4 are the correct option, all are wrong. Now question number 4, the electric potential decreases uniformly from 120 volt to 80 volt as one moves on the x-axis from -1 centimeter to x is equal to +1 centimeter. The electric field at the origin. If this question comes as the numerical, we can solve like this: E is equal to minus dV upon dr. dV change in potential 120 minus 80, and the dr minus 1 to 1. So final minus initial, we are taking E, or we are getting E as 20 volt per centimeter. So this value would be there, 20 volt per centimeter. So B option seems to be correct, may be equal to 20 volt per centimeter. But other two options, if you see, may be greater than or may be less than. For that we have to think that electric field, or we have to know that electric field is maximum along the direction in which the potential decreases at the maximum rate. But in this particular question, direction in which the potential decreases at the maximum rate may or may not be along x-axis, because it is saying that on x-axis it is first 120 volt, then 80 volt, but it is not saying that this decrease is maximum along the x-axis. Now from the given information, the direction of maximum decrease in potential cannot be found out accurately. So E can be greater than V 20 volt per centimeter in the direction of the maximum decrease in the potential. So there is a possibility it is equal to 20 volt per centimeter, may be greater as well. So B options and C options both are correct in this particular question. Question number 5. Which of the following quantities do not depend on the choice of zero potential or zero potential energy? See, if we think about potential of a particular body, charged body, potential energy of a particular system, that always depends upon the frame of reference, I mean a point of reference. But when we think about the change in potential energy or change in electric potential, that does not depend upon the choice of zero potential, whether it is infinite or any other point. So potential and potential energy depend on the choice of a reference point or zero potential energy, but the difference of potential and energy does not depend on the choice of reference point. The change or the difference does not depend. Question number 6. An electric dipole is placed in an electric field generated by a point charge. Electric dipole is placed in a field generated by a point charge. Look at this particular point charge, and these are the field. Let us now place this particular dipole here. So on positive charge, field due to the field force will be along the line or the field line, that is QE, and on negative it will be opposite to the field, so that is radially inward. Look at the QE dash and QE. Do you find it equal? Obviously not. Even directions are not exactly opposite. Point of actions are different. So in this situation, what we can say, the torque on the dipole due to the field may be zero, means it may not be rotating, rather only translating from one point to another, because here force is not going to form the adequate amount of couple or torque which is going to rotate the particle. Question number 7. A proton and an electron are placed in uniform electric field. There is a proton, there is an electron placed in uniform electric field. We know that both are having same amount of charge, E 1.6 into 10 raised to minus 19 coulomb. Force on both will be same, F is equal to QE, and force on both same. It does not mean that the acceleration would be equal, because their masses are different. Electron is much lighter than the proton, around 1837 times. So acceleration will not be equal. Electric force on both on them will be equal, or magnitude of force would be more precise, the correct option, because acceleration on both means directions also may be involved. So on that note, B is the correct option. Question number 8. The electric field in a region is directed outward and is proportional to distance r. So let us write E is directly proportional to r. Then E is equal to kr. Now the question is, taking the electric potential at the origin to be 0, it is uniform. We have to find basically the relation for potential where electric field is directly proportional to r. So E is equal to, we know the relation, minus dV upon dr, or dV is equal to minus E dot dr. So let us put the value as minus kr dr. Now integrate it. After integration we will be getting k, r power is 1, so after integration it will be r square upon 2 plus c. C is the integral constant. So if you look at the mathematical calculation over here, V is directly proportional to r square. It means option C is the correct option. Only one option would be correct out here. Thanks for watching.